everyone. Oh, I've got a bad joke to tell you. You ready for it? William, this is for you. You ready? Okay. What do you do if you get attacked by a group of circus performers? You go for the juggler first. Juggler? Oh, God, that one died a death. Tess, get me out of this hole. Have you got a bad joke for us before we get started?
I'm sorry, I do not have a bad joke. And my daughter even told one yesterday, and I just can't.
You can't remember it?
I don't remember it.
Okay.
If I think of it, I will
Jump in and tell us.
Add it,
Okay.
yes.
Okay, everyone.
I got a really bad one.
Oh, great. Go for it, Keith.
Since Tess dropped the ball and come through, so I'm going to go ahead and rescue her here. Where do European countries keep their armies?
I don't know. Where do European countries keep their armies?
Up their sleeves, of course. And you're welcome.
Oh, God, that is bad. Do you know Switzerland's not that very interesting, but its flag is a big plus?
I like it.
Oh, God, that one got to someone. Okay, good morning, everyone. Time for us to get started. So what I've got here is essentially antiderivatives, and I've tried to put them together in a little table, you know, like we did when we did differentiation. Let's introduce you to some notation, because when they ask you to find an antiderivative, there's three typical ways that they do it. The first two are very common. The last one happens occasionally, but isn't that common. Sometimes they will give you the question and they tell you what the derivative f dash of x is equal to, and then they ask you to find the original little f of x. Sometimes they will they'll tell you what f of x is, and they'll ask you to find capital F of x. So if you ever see, here is a function, little f of x, find capital F of x, if you ever see that, they have just told you to find the antiderivative of this guy. And in this case here, you're told dy by dx is this, and they ask you to find y. These are all the same question, right? They're all asking essentially that you find the antiderivatives. So here's a list of the major guys, although there's a couple I'm sure I'll add to the list as we hit them, on how to find antiderivatives. And I'm going to use I'll tell you what f of x is, find the capital F of x notation. So here is the function, and here is what its antiderivative looks like. This one here is actually a formula, and it's the one that we talked about yesterday mostly, and it's called the power rule. So it's a power rule for antiderivatives. So you use this rule if you want to find the antiderivative of 4x squared, 5x cubed, 10x, right? Anything like that. And the rule as a formula looks like this, but I tend to do it as a sentence. Add 1 to the power and divide by the new power. So if you want to find the antiderivative of this guy, you would add 1 to the power, and then you divide by the new power. And if you want the antiderivative of that guy, you get 3x, and then you can finish with your plus c. Now, if you want to find the antiderivative of e to the x, it's just e to the x plus c. I think that's almost the last one we did yesterday. 1 over x is the natural log of x. You will also find out that it sometimes has the natural log of the absolute value of x. That's very flexible. Is it an x? Is it an absolute value of x? The reason I'm saying it's very flexible that in some cases they put the absolute value in other cases they don't bother. And it's almost like hit and miss, why did they put it here, but they didn't put it there? And the reason why it's even necessary at all in this one special case is that the log function doesn't exist for negative numbers. So if you put an absolute value around it, it avoids that case. But you could just get round the situation by simply saying the antiderivative of 1 over x is this guy, as long as x isn't negative, right? And everybody said, well, I wouldn't use it if it was negative. You know, like I wouldn't use a negative number inside the square root. You know, we don't normally stick absolute values inside them, right? We all assume that you're not going to do it because, you know, it doesn't exist. It's a little bit different from 1 over x, but essentially it's the same thing. And then 4 of the trig guys. If you have a sine x, its antiderivative is negative cosine x. If you have a cosine, its antiderivative is sine x. Do you notice that that's like differentiation, but the exact opposite sign? If you differentiate a sine, don't you get a positive cosine? If you find the antiderivative of sine, don't you get a negative cosine? Do you notice that there is a difference, right? That's probably the most common mistake I see whenever I see antiderivative questions, right? Because your brain is kind of in the differentiation mode, and so you sometimes get the sign wrong. Secant squared is tan x. How do I know that? Because I know the derivative of tan x is secant squared x. In fact, if I put over here a table, here is the function, here is its derivative, right? Imagine I did a table on my left here, functions, on my right, the derivative. See if I pick that table up and switch places, haven't I now got an antiderivative table, right? So if I know what a function's derivative is, I can switch places, and now I know what a function's antiderivative is. So for instance, if you differentiate a secant, don't you get a secant tan? So the antiderivative of secant tan is secant, right? So if you see something and you say, oh, I'm trying to find its antiderivative, you're really trying to find a function that if you differentiated it would get you that guy. Any questions so far? Right, got a lot of table, basically a lot of things to memorize. Let's nip over to the homework.
What about
Hmm?
what about
Yeah.
cosecant and cotangent?
As a single value? You know, what's the antiderivative of secant x? Thing like that, Keith?
I can't. Yeah.
Yeah. You won't like the answer to them. They're ridiculously ugly, so you're not going to see them in my class. When you do Calc 2, I'll show you the antiderivative of secant x. And off the top of my head, it's the natural log of secant x plus secant tan x. There, you wouldn't have expected that, right? It's totally weird, right? So it doesn't, you know, they don't all come out nice. And so, but we don't need to worry about that because we're not going to do those guys. We will do the guys on my list, of course, and let's have a look at them. I want you to see the homework the way you would do it. And they're going to start off really, really simply. And they're doing the, here is f of x, find capital F of x. Now, 7 will get you, maybe I can use this keyboard. Oh, good. 7 gets you 7x, technically, plus a c, right? And this one, you would add 1 to the power, so that would be what, t cubed? Why am I in capitals? Go with capitals, right? T cubed, and then you would divide by the new power. Well, 27 divided by 3 gets you 9, and then you add the plus c. Now, I am going to hit submit, and it is going to tell me I'm wrong. Darn it, it told me I was right. Okay. What I thought it was going to do is that, do you know how sometimes WebAssign is pernickety? Right? I thought it might want the C to be a plus little baby c. It does that to confuse the heck out of me sometimes, but evidently I was cruel to it because it will take that. I want to try something. Will it take a baby c? I'm just wrong. it doesn't care, right? Which is good. I wonder why I thought it didn't. If you wanted to do this guy, wouldn't the answer be cosine Q or negative cosine Q? Because only one of them's right.
Negative,
What would you get? Say again, Matthew?
negative cosine Q.
Correct. If you wanted to do 4e to the x, my favourite function in the world, I like e to the x, as you know, isn't its antiderivative 4e to the x plus c? Okay, now I'm going to go for e to the power of x plus c. And this guy we decided was negative cosine of q. And I've got too many brackets there. And, oh, I want to try some. I'm going to deliberately forget the plus c. Let's see what WebAssign thinks. Bah! Oh, I hate WebAssign. Naughty, naughty WebAssign. Do you notice I took my answer without the plus c? You are naughty, WebAssign. Do not get into that habit. If you do that in the test, I'll take a point off. If you forget the plus c, you're losing a point. So don't do it. Right?
Professor,
Yes.
for the first 4 or 5 questions in the homework, they don't
Yes.
worry about it, but later on they do mention it. Yeah, question 4 right there tells you to do it.
Okay, so that's bad plan. Shouldn't they just have started in question 1 and say, hey guys, plus c.
I agree.
Don't get into we'll be a bit generous for the first 3 or 4 questions, and then we'll make you do plus c, because that's just going to cause problems. I don't like I'm talking to a machine and it's a software, but I don't like them doing things like that. Okay, we'll get 5t, there we go, and plus a c, and oh, here's one that might cause a problem. Where is theta? I have to plug it in to do the answer. Where do you get theta?
By typing it.
Type
You
in
have
the
to-
words.
If you go into
Theta.
Greek, if you go into Greek on the right side, it's also in there too.
Okay. So the way I type that one in is I actually, as you can see me doing it, if you type in theta, it will do it for you. And just as Craig was saying, if you hit the Greek tab, you'll be able to hit that one and get theta, right? Right. Are we getting a little bit comfortable about just finding antiderivatives of functions? Okay. Type them in, put in a plus c, whether or not WebAssign is being generous and allowing the flexibility, I don't care. You should always do plus c's because that's the proper 100% right answer. So let's just do some polynomials. Basically, let's do a lot of them. And I'm going to start off with a straightforward one. And then we're going to do some sneaky ones. And I'm going to stick to, here is f of x, find capital F of x. So you might get, all right, you might get, find the antiderivative of this guy. Well, whenever you deal with polynomials, you're basically using the power rule. So add 1 to the power and divide by the new power. Well, 3 divided by 6 gets me a half. Add 1 to the power, divide by the new power gets me 4/3. Add 1 to the power, divide by the new power gets me a half. And 2 gets me 2x, and then finish with your plus c. And what? 1 minute, a question, right? Polynomials are pretty obvious, right? Add 1 to the power, divide by the new power. If it's a number, just call it 2x because that's less work. And remember to finish with plus c. That's my first one. Now, this is new. I would like to find the antiderivative of this function. not really written in a very helpful way, is it? What could I do then to rewrite it in a way that would allow me to find its antiderivative?
Simplify.
Okay, and by that we mean, I'm assuming that we're going to FOIL it, right? So what do I get? I get 2x times x gets you that guy. I get a plus 4x, I get a take away x, and I take away 2. And so I now have 2x squared plus 3x take away 2. And then I can find its antiderivative. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and you're done. So you may be given a function f of x written in a format that isn't lending itself to these guys here, right? To being an antiderivative, right? It's kind of messing, you know, playing with your head a little bit and messing things up. So now I'm going to do something over here. I want to find the antiderivative of a square root. There's no square roots here. Yet we can still do it. If I wanted to differentiate it, wouldn't I call it 4x to the half? If I want to integrate it, I should also write it as 4x to the half. Because see this power rule? That number, that power there, doesn't need to be a whole number, right? It doesn't need to be x cubed or x squared or, you know, x to the 10. It can be x to the half, it can be x to the 3/4, it can be anything you like. The power rule still works. It's just a bit uglier, right? The number's a bit uglier. So it's antiderivative. Here goes. I want to add 1 to that power. Well, if you add 1 to that power, it's 3/2. Then shouldn't I divide by the new power? Right? I should divide by 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. So adding 1 to the power and dividing by the new power gets me 8/3. If you don't believe me, dividing that is the same as multiplying by that, which is 8/3. You comfortable now? Right. Plus C. Oh, wait a minute. Style points. Should always make your guy look like the original. So style points for antiderivatives are really only got 2 rules rather than 3. The normal rule for differentiation in algebra and so on is number 1, make it look like the original. That's rule number 1. Rule number 2 is factor the heck out of it. And rule number 3 is if you've got a trig function, look for an identity if there is one to make it look pretty. Right? That's your 3 rules for style points.
I got a
Because
question.
yes. Good Keith.
So,
Question.
so when you say factor the heck out of it, as far as style points, then shouldn't it be 8/3 x times the square root of x plus c instead of square root of x to the third? Shouldn't we factor out an x?
Oh, so you could do that? I would say yes, you can do that. And if you don't, I would say yes, it's still okay. And why can I get around that? My version is a square root. Your version also has a square root. Your version is actually slightly nicer, but both are okay. I wouldn't be too concerned about that. Right. Now, I said there's only 2 rules when you do antiderivatives. Make it look like the original, whichever version you think looks prettier. That's rule number 1. There is no factor the heck out of it, and that's because of the plus C. So you don't need to worry, oh, I'll look for a common factor and all that kind of stuff. Don't matter. You don't need it. Rule number 3 is if it's a trig expression you end up with, look to see if you can, simplify it. It's still there. So that's how you take care of square roots. Suppose I had to do the antiderivative of that guy. Well, the first thing I would do is rewrite it as a fractional power. And then I can do the power rule. I will add 1 to 5/3, which gets me 8/3. I will then divide by the new power. Dividing by 8/3 is the same thing as multiplying by 3/8. If you multiply this guy by 3/8, you get 18/8. Of course, if you see it coming, you should simplify it in your head and just write that guy down. Okay, add 1 to the power, divide by the new power. It is still the power rule, even although we're dealing with fractions. How about this guy? Really ugly function. It's made up of 2 fractional powers of x. I can do its antiderivative. Add 1 to this guy. Well, -1/3 add 1 gets you +2/3. And if fractions are not your thing, especially when the fractions are really ugly, you can actually do it on your calculator. So here we go. -1/3, add 1, then math button, fraction, boom, right? 2/3. So add 1 to the power. Dividing by 2/3 is the same thing as multiplying by 3/2. So if you go 4 and you multiply it by 3/2, you get 6. So if fractions are not your thing, your calculator can do most of it for you. Right, this one here, if you add 1 to that guy, you'll get 7/4. Divide by the new power is the same as multiplying by 4/7, and so you get 8/7 plus a C. Now, if you wanted to check that that really was the real answer, couldn't you differentiate that and you'd get back here? So if you differentiate that, you get this. If you differentiate that, you'll get this. So that's how you deal with square roots, cube roots, and fractional powers, right? You can still find their antiderivatives, right? Add 1 to the power, divide by new power. How about this guy? Well, he's a fraction, but he is actually in my list. And he is 10 natural log of x plus c. Well, how about that guy? He is not in my list. Can anybody tell me a different way to write that that's going to make it easier to find antiderivative? Because right now, I can't do the antiderivative on it. Think of what you would do if you had to differentiate it. What would you change it into?
10 times x to the -2.
Great. Now, if you can write it as a power of x, you can find its antiderivative. And this time, you're going to add 1 to the power, which is -1, divide by that new power, gets me that. And almost got it wrong. Capital F of x, right? And then some style points. Are you finished? How about this fella? I want to find the antiderivative of that guy. Got to figure something out. It can't be done right now.
I would say that it's the numerator, the quantity of the numerator times x to the -1.
You'll agree with that? You're comfortable with that? Which gives me what, 3x? That times that gets me 4. And that times that, I could call it 5x to the -1, but I'm actually going to write it as 5 over x instead of 5x to the -1. Because if I write it like that, aren't I going to see its antiderivative a lot easier? So what we do now, well, power rule. Add 1 to the power, divide by the new power. 4 gets you 4x, and that guy gets you 5 log x. Well, when I did this guy and I decided to write the answer as 5 over x, let's see what would happen if I just didn't notice that I could write it as 5 over x. Let's suppose I had it like that. And I'd say quite naturally, okay, it's a power rule. I'll add 1 to the power. Ooh. And then, oh. Do you see that the power rule doesn't work for 1 over x or 5 over x or x to the -1, which is essentially the same thing? Does that become a little bit more obvious why I needed to write it like that? Because 1 over x is a special case. The power rule does not work for 1 over x or 10 over x, right? Anything over x. Let's change letters. This is a version of question 9 homework.
I think on the last one, didn't you forget the plus c?
I just lost a point. I did. Yes, well caught. So we have a 2t, take away a 4, plus 7 square root of t, all over the square root of t. Okay, now, the fact that it's a t and not an x makes absolutely no difference, right? I could turn it into x's and it's the same question. What we have a problem with is that we don't have anything in here that looks like that. So you probably don't need every single one of these lines, but I'm going to do them anyway. First thing I'm doing is turning those square roots into half powers. I know that, right? I know I'm going to have fractions powers. I'm then going to do essentially a version of the same question we did a minute ago. I'm going to multiply through by -1/2. That guy times -1/2 gets me 2t to the half. That guy gets me -4t to the -1/2. And that guy times that guy just actually gets me 7. You all comfortable with the algebra that I've done there? Right, turn everybody into half powers. The half there becomes a multiply by -1/2. Each of these terms, if you multiply them by t to the -1/2, gets you this guy, gets you this guy, and gets you that guy. Now I can find the antiderivative. Add 1 to the power. Divide by that, it's the same as multiplying by 2/3, so that gets me 4/3. Add 1 to the power. Dividing by 1/2 is the same as multiplying by 2. That guy, and this time I'll remember keep my plus c. We are beginning to do antiderivatives of things that don't even vaguely look like this. but we can still do it. And it's all been the power rule. Every question, with one exception, was the power rule. Well, let's change tack and do things
Don't we
that
have
aren't
to-
power rules.
Don't we
Sorry?
also go back and make it look like the original?
On the ball today. Yes. And I was that happy I did it right. I forgot to keep going. Yeah, style points at the end. Make it look like the original. And be careful. It's a very bad habit, which I've already done twice today. There's a 99% chance if you type that into WebAssign, it'll give you the points, even though it should be that. So be aware of that. Right. This one is similar to question 11. We've got a function theta, and it's 7 sine of theta. Take away 6 secant theta, tan theta. And, you know, they put intervals on things. They don't need to, but I guess it keeps, you know, the math lawyers happy. Right, if you want to find the antiderivative of 7 sine theta, you just go down here and say, oh, the antiderivative of sine is a negative cosine. A secant tan gets you a secant. So negative 6 secant tans gets you negative 6 secants. And I'm certain there's nothing that I can do style point wise to make that nicer. Are we good? Let's throw a cat amongst the pigeons.
What was that?
The cat amongst the pigeons. You never heard of that phrase?
No, but I have now.
Right. The phrase, let's throw the cat amongst the pigeons, essentially means let's cause a lot of disorder. Let's throw something weird into, you know, jumble your brain up, right? So here is a function. It's not on my list yet, but I can still find its antiderivative. I just have to have a good memory. Somewhere in your list of things that you know how to differentiate, there's a function that you differentiated it and it gave you 1 over 1 plus t squared. Who is that guy?
The tangent inverse.
There you go. Now, do you see in that question, the only way you could answer it is by having a good memory, right? I've done so many differentiations in my life. I know what that guy's antiderivative is, right? Just memory, right? There's no power rule or whatever. You just remember it. Actually, isn't that how you do these? You just remember it. Now, if you stick a 10 there, doesn't the answer just become 10 of those? How about this one? This one is definitely going to test your memory. There is a function out there, stick the 10 there, whose derivative is 1 over 1 minus x squared.
Inverse,
So the antiderivative. Right, quick. What was it?
inverse sine.
Inverse sine. That's not in my list. But I mean, as we go through them, shouldn't I be sticking more and more things on my list? But really, I'm just saying, yeah, it got to be somebody I can do, right? It's got to be something that I already know from past experience what is equal to. And That's what that one is. Well, that's us finished just practicing at finding antiderivatives. Now we're going to do questions where we find the value of that plus c. So imagine I give you a question that looks like this. And I ask you to find capital F of x. And I also tell you that capital F of 2 is 10. That extra little piece of information here is going to be how to find the missing plus c. So let's see how we would tackle that. We begin with our polynomial and we find its antiderivative. And that is add 1 to the power, divide by the new power. Can I change that number to 1 just to make my life a little bit easier? Plus x squared, take away x, plus our unknown c. And that would be the antiderivative, right? I know what f of 2 is. It's 1/4 times 2 squared, 2 to the 4, sorry, plus 2 squared, take away 2, plus c, and it's equal to 1. Now 2 times 2, that guy gets you 4, that guy gets you 4, that guy takes away 2, that guy gets you c, and you get 1. 6 add c gets you 1. Take away 6 from both sides. You now have -5. So you can write down the complete answer, which is 1/4 x to the 4 plus x squared, take away an x, minus a 5. So this is the antiderivative of this function where one of the answers, capital F of 2, is a given value of 1. And so this is the, well, that's it. Basically, it's the answer. So far, so good. So we're going to still find antiderivatives, but we're also going to find the value of the plus c. So here is a version of question 14. F of x is going to be 7, take away 3 lots of 1 plus x squared to -1. That's kind of weird. And we're being told that f of 1 equals 0. That guy will be used at the end to find the plus c. That guy is not the power rule. I know it's written in a form that makes you want to use the power rule, but isn't the power rule only for x's? It's not for 1 plus x squared. So power rule ain't happening.
Yeah, it's the inverse of tangent.
I do. If I rewrite it like that, do you all see the inverse tangent a little bit clearer now? So just because a question is written in one particular way doesn't really mean that's the best way it should have been written, right? In this case, writing it like that does make it clearer how you're going to find the antiderivative. Okay, so far so good. Now, I know what f of 1 is. It's 7 times 1. Take away 3 times the inverse tan of 1 plus c. And that should equal 0. Well, that's 7. Take away 3 times the inverse tan of 1 is pi over 4. Add c equals 0. And if we subtract 7 from both sides and add that guy to both sides, we will get 3/4 pi take away 7. So the complete answer for the antiderivative, capital F of x, is 7x take away 3 inverse tan of x's plus a c, which happens to be equal to that guy.
How did we get the pi over 4?
Okay. We're trying to solve what's the value of the inverse tan of 1. Right. And what that essentially is, what angle has a tangent of 1. And if you go to your unit circle, you'll find a guy over there where the x and y coordinates are the same guy, right? They happen to both be √2/2. And the angle that makes that happen is pi upon 4. So I know that the inverse tan of 1 is pi upon 4. Right? So you're trying to find an angle whose tangent is pi upon 4, and the angle that works for is pi upon 4, right? I think I said that wrong. You try to find the angle whose tangent is 1, and the angle that does that is pi upon 4. That's what you should have said. Right, let's throw some more cats on the pigeons. Let's get ready. And this is a version of question 15. And sometimes the simplest questions can be the worst to deal with. This one is not interested in you finding, you know, an antiderivative and then finding C as we did the last 2 questions. You're only being asked, right, to find f of x. So we are going to be using this notation, right? But wait a minute, it's not f dashed of x is this. It's the second derivative of x equals this. How on earth am I going to get back to the start function? Well, I'm going to use antiderivative process. If you find the antiderivative of this, you add 1 to the power and you divide by the new power, and then you do a plus c, agreed? What is the antiderivative of f double dashed of x? Well, if you do the antiderivative on this, what do you get?
F prime of x.
And we get 1 of them. Now, if the question was find f dashed of x, you're good. Now things get sneaky. Can I now do the antiderivative process a second time? Now, the antiderivative of this guy gets you f of x, which is what we're trying to find. Add 1 to the power and divide by the new power. Okay, I haven't had to cope with this situation. Now it happens. What's the antiderivative of plus c?
Cx.
Now, I am going to put another arbitrary constant. And I'm not going to call it plus c. I'm going to call it plus d. Right, it's just another different letter of the alphabet. Why is this arbitrary constant? Because every time you do an antiderivative, shouldn't you finish with a plus c, right, after you're finished? Why am I calling this guy plus d and not just plus c, the same letter as that guy? What's the reasoning behind it?
They should have different values.
Right. Couldn't this guy be 10 and then this guy be 20, right? There's no reason they should be the same. If you say cx plus c, aren't you committing to both numbers being the same? And there's no reason why, when you find an antiderivative, that the arbitrary constant is always the same each time you do another antiderivative. There's no reason for it. So we're done. How about a version of 17? The triple derivative at t is 24 plus the cosine of t. Right, and we're being asked to find the original function f of t, right? Now, since that's a third derivative, doesn't that mean I'm going to antiderivative 3 times? I kind of know the process. If I do my first antiderivative, 24 becomes 24t, and the antiderivative of a cosine is a positive sign, and then you have a C. Now I'll do an antiderivative again. So I now have f dashed of t. Power rule for this guy. Add 1 to the power, divide by new power. The antiderivative of a sine is a negative cosine. The antiderivative of plus c gets you ct. Think of that as plus 42. And then we need a different arbitrary constant, right? Another one, plus t. Kind of what happened here, right? Now I do the antiderivative one more time. And now I'll have f of t. Power rule. Add 1 to the power, divide by new power. If you find the antiderivative of negative cosine, well, a cosine gets you a sine, so a negative cosine should get me a negative sine. Now, what would this guy get me? Well, wouldn't you add 1 to the power and then divide by the new power? And then you get dt. And wouldn't you have to finish with yet one more arbitrary constant? And since we have no imagination, aren't we going to call this one E? You add C, you add D, you add E, you add F, you add G, you add H, right? If you had to do it 5 times, each time one new guy. Now I'm going to try something out. This guy is in the homework. And we have 4 t cubed. And take away sine t. Add.
You're still in the index position, sir.
Oh, out of there. Take away. Good place. Sine of t. There we go. Got that guy. Plus, well, c over 2t squared. That's the easy way of doing that. ct squared. Right. And over 2. There we go. And then a plus dt, and then a plus e. And I'm going to do submit answer. He didn't like it.
Is it because the t squared is in the numerator and the
No, it's because
c
of
over
the
2?
E. The instructions
Oh,
say to
yeah,
use F.
I forgot. No, I didn't do that. But I'm going to try this. Okay, there's something I've
The
done.
letters need to be capitalized.
And instead of e, it wants
It should
f.
not be E, it should be F. The instructions say to use F.
Right.
Shouldn't
So-
it be,
No,
Shouldn't
I
it be-
like. Well, yes, Keith, what you saying?
shouldn't it be C over 2 to the second power?
Shouldn't it be what again? Sorry.
I thought you had written down that it was in the for F, it's yeah.
Right. First suggestion is just call it F. Didn't like F.
Cap.
It wants capital letters.
Well, it's capital letters now. All we're doing here is trying to figure out what. See.
Well,
What
were
is
you-
causing
Were you doing it?
Website E to get all confused? Let me try this one, then you can tell me what you're thinking, Keith. Okay, where are we off to next?
Just capital
The
F.
question is right. I'm just trying to figure out how WebAssign understands it. William.
Wants a capital F instead of a capital E.
I hope I don't run out of letters in the alphabet. Right. Would you agree, everybody, that that was just being pernickety, right? It was not that I got the answer wrong. It was I just had to figure out what on earth it was looking for. It didn't like capital E. That was essentially it. Or it didn't like little e, and then it didn't like capital E. I want to try one more thing. And it should actually do this. Whether it does is a different matter.
You ran
Is it
out of attempts.
Because it
Oh,
looks
ran
like
out
you
of
ran
attempts.
out of opportunity.
If someone has got a chance to do this, will you put in CT squared there instead of C over 2t squared? If someone's got a chance, tell me if it's accepted.
Would it not
C-
like E because it actually has a value?
E is exponential base, right? It's just like putting in pi, right? You're not putting in a constant. At least WebAssign is doing it as that. To me, capital E would be fine, wouldn't it? You don't know what I'm talking about if you do it by hand. In fact, if you did all those answers that it just told me I was wrong in a test, you'd get them all correct, right? Because they're all really the same thing. Has anybody found out, does it take CT squared? Nobody's got it done. Okay, I want to, can't do it here because there's no more
I've
CT
got
squared.
WebAssign up. I'll go ahead.
Go and try it then. I hope it does, because if it does, I can show you a little trick. If it doesn't, I'll still show you the little trick and then tell you don't do this because WebAssign doesn't like it, right? But there is a slightly different version of the same correct answer that I want to show you. But I want just a few moments to get a backup verification before I do that. Right, while we're doing that, I'll get set up here.
Okay, so you wanted me to do what now to that one?
Everything here, I want you to write down your version, because they might change the numbers on you. Well, we'll have to put F there because we know it doesn't like D. But essentially, I want you to put C there instead of C upon 2.
So the number it gave me was 48.
Okay, so you would change, okay, if that's
Oh,
48,
you know what?
this will turn into 8t cubed for you then.
I noticed something in the question also. It specifically said to use capital C, capital D, and capital F for the constants.
It did. Right. But make that just a capital C, not a capital C over 2.
Yes, it's saying it is correct for C, capital C, T squared.
Right, perfect. Now, that's the answer I had, and it took it. That's a slightly different looking answer. Yet both of these are correct, and they are. So what is the logic behind that? Well, obviously, C and a half C are not the same thing, right? I mean, it's pretty obvious one of them's half the other, right? But why is it mathematically still okay? Well, I do not know what C is, right? It's an RPG constant. If I don't know what it is, I also don't know what C over 2 is, agreed? And since I don't know what any of them are, can't C be used to represent I don't know who you are? So I don't know how many t squared you are. I don't know how many divided by 2 t squared you are. Equivalent math, right? So you could have plus C over 3 t cubed, right? Just for argument's sake. You can write that down as just CT cubed, and mathematically it's totally equivalent, right? If you don't know what something is, dividing it by 3 doesn't make it more knowable, right? It's still unknown. So it's a little idiosyncrasy. It just looks prettier for me. Doesn't that look a little bit nicer looking than that? I mean, it's not a big deal, but it is what it is. So we kind of petered out with a little C over 2 equals C, but we've actually finished Calc 1. There's nothing else new to learn. So for the last few moments, then we'll let you get on with your own, getting ready for your final. Tomorrow is going to be revision day. So tomorrow is up to you if you turn up or not. You'll be given attendance for Wednesday either way. You might only want to turn up and ask, hey, could we do another linear approximation? I'm not sure if I'm doing it right. I want to just see what it looks like. And that's all I need, and then you leave. You can turn up and watch and ask your own questions for the entire period. You can choose to study at home and get ready for the final. I really want you to use that tomorrow the best way it's going to be for you. That doesn't mean you can't come and look at the video afterwards and get like 2 for the price of 1, where you get to, you know, do one and watch other people's questions. Whatever works for you, totally fine with that. So let me give you a little bit of an idea of this question, or the answer to this question. What do I need to get in the final exam to get a 2.0, which is a pass, and that allows you to move on and do Calc 2, to get a 3.0 because I want it, or to get a 4.0 because I really want that. So what do I need to get in the final exam to get a pass, a 3.0 or a 4.0? Now, what I'm about to tell you is not perfect, and the reason it's not perfect is there's a little wiggle room still going. Don't you have one more online test? You could get 100 out of it, which case your grade might move up 1%, right? It's not going to move up a lot unless, you know, everything was 50s and you suddenly got 100. Then it might move up a bit, right? But most of it's going to move up a couple of percent. Might go down 1 as well. I guess that could happen, but that would only happen if you'd missed 2 tests. So even for you, it's unlikely. You've got, what, 2 homeworks to go? Out of the big scheme of things, it's probably going to move another %. So pretty much what you've got right now, give or take a couple of %, is accurate, right? So there's a little wiggle room, but not a lot. So what you're going to do is, the first thing you're going to do is get your percentage. So right now you might have 82%, right? William's got 94 and Robert's got 17 because he's not very good and he never does his homework, right? And the reason I said that is because none of those things are true about Robert, but you know what I'm getting at, right? You've got your number, 82%. So now what you do is you find 82% of 700. And that's a fixed number. So I'm going on my calculator and I'm going 82 times 700. And in this case, I get 574. I'm going to call that your base number. That's your base number, right? In your case, Matthew, your base number might be 600, right? Whatever it is, base number. Now, if you want to get a 2.0, you need to get a total of 750 points. So what you do is you take 750 and you subtract your base number from it. So in this person's case, you go 750, take away 574. So here's 750, take away 574, and that gets you 176. So if you want to get a 2.0, you need to get 176 out of 300 in the final exam. Okay, so that's the first one, right? What do I need to do to get a 2.0? This person needs 176. You take 750 and subtract your base number from it. Whatever's left, that's what you need to do in the final. Okay. Now I want a 3.0. Let's suppose that's my target. Right. Well, to get a 3.0, you need to get a total of 850 points. So in the final exam, what do I need? Well, you go 850, take away your base number. 850, take away 574, and that gets me 276. So if you want a 3.0, you need to get 276 out of 300. And if you want to know what that is, you need to get 92% in the final. Now, if you wanted to do this one, you need to get about 59% in the final. Now, for some of you, your goal is a 4.0. This particular person, I know he's not going to get it, right? I can tell before I even do the calculation that a 4.0 is not in that person's cards. So let me pretend I've got someone else, and let's pretend that your base number is 674, right? Now that person has a chance of getting a 4.0. Let's see how that works. To get a 4.0, you need to get a total of 950 points. So in the final exam, this person is 950, take away their base number, 950, take away 674, and that's 200 and something, 276. Oh, it's the same, basic. So for this person, they need to get a 4.0, they need to get 276 out of 300. So they also need to do about 92%. So are you all comfortable about what you need to get your 2.0, your 3.0, and for some of you, 4.0? Right. So that's your goal. Obviously, you want to do the best you can. So let me depress you a little bit. It's just reality. You have to be aware of it. Doing a final is much harder than doing online tests. It's much harder than doing your midterm because it is the entire volume of work, right? It's from week 1 to today. There are tons of things in there, right? Lots of things that you've learned and maybe haven't seen for 4 weeks or a month or whatever, and you can get caught out. It's just a lot of things to know. So you're going to have to be aware that if you don't prepare for everything as much as you can, then you're going to find some questions that you either don't know how to finish, or you may not get them correct because you're not doing the right method. So what am I getting at? You got to prepare. Murphy's Law, half the things you study for will not be in the test. Right, so you're going to spend a lot of time learning how to do, top of my head, logarithmic differentiation. Remember those guys? Logarithmic differentiation, right? And then I don't even ask you a question. And you might say, oh, he's never going to ask me a question about implicit differentiation, so I'll not bother studying it. And guess what? I'll ask you a question on it. That's Murphy's Law, right? So you got to be aware that everything that you've been taught can happen. So I'm going to give you some exceptions to that rule, okay? I am not going to ask you any questions to do with the delta epsilon. Remember the formal definition of a limit? We did like 4 questions. You're not going to get that question, so don't worry about that one. So you can check that off your list. You are not going to get a question, directly at least, where I ask you to use calculus to draw the graph of something. Those questions take forever and a day, and you could probably do them in Desmos. What I could ask you, however, is tell me when the function's increasing or decreasing and where its local max and mins are. Tell me when a function is concave up or concave down and where its points of inflections are. I can ask you those. I just won't ask you to draw the graph. Right. Now, if I wanted to ask you, which I don't, couldn't you just go to Desmos, draw the damn thing, and then just copy a sketch of it, right? So there's no point in me asking you that question anyway, because Desmos does it all for you, so why do I need to, right? But I can ask you the details, right? The calculus part of it, in there. What else? Your final exam is, for the most part, chronological order. I've already written it, which is unusual for me. I tend to write it after we've done revision. That way I feel more comfortable about talking about anything, because I know I haven't, written the test or the final, but I have. So it is what it is. So bear that in mind. None of your test is on WebAssign. It's all going to be written down work. So I'll see everything that you need to do. So you'll show me the working. Questions?
Yeah, Professor, I'm gonna have to take off. I've got an appointment that I got to drive across the
Okay.
county.
Look after yourself, Keith. Remember to put your attendance thing if you haven't already done so.
Already did.
I tell you, yeah, you can catch this up anyway, but I was going to say, here are some topics that I'm not giving too much away by telling you you're going to get. You are going to get a product rule, a quotient rule, a chain rule, right? There's no way in the world I'm not going to give you questions on product rule, quotient rule, chain rule. I am also going to guarantee to give you a question on antiderivatives. So you're going to get, who knows what version of it, because we've done different types of questions, but you're going to get one. So bear in mind those guys. Those are kind of the bread and butter. I really do have to test that you know how to differentiate things, right? Any other questions? That's the last of what you're guaranteed to see.
Will there be a section where you don't show your work, like for matching, like what we had on the midterm?
Yes, there are going to be 2 parts. Section 1 is multiple choice, where you don't show working. You just basically tell me it's A, B, C, or D. And then section 2 is going to be, the major stuff, where you show working.
How many questions is it going to be?
That's a great question, and I can't remember. So if you hold off for a second, I'm going to go and tell you. And if the final exam appears when I do that, you will be honest and look shocked, so I can close it down really quickly, because you're never quite sure. Are you looking at my summer 2022 screen? Be honest. Okay, so now I can go in and do it then. Right, so where did I put the finals? I put them in here. I think I put them in here. I don't know where they are now. I've lost my final exams, guys. Well, I've done them. I just can't remember where I put them. Here we are, right at the top. And click on it. Okay, there are 10 multiple choice. And there is going to be 10 section 2s. The multiple choice is worth 5 points each, so that's 50 points. And section 2 is worth the other 250 points. So 50 points in multiple choice, 250 in the others, and that's it.